zkRollups, parachains, sharding, ghostDAG. There are so many scaling solutions out there, each one claiming to be the best. So how are we supposed to make sense of all of them? Well, that's what we're trying to do in this short video with my co-founder and Koinos blockchain architect, Michael Vandenberg, because one of the things that sets Koinos apart is that it wasn't designed for any specific scaling solution. It was designed to be rapidly upgraded with whatever solution proves itself in the marketplace and fits the needs of Koinos at the time. So it doesn't have a dog in the race, but since it's the first and only free-to-use blockchain, it's also only a matter of time, which means we need to be paying careful attention to the different options that are out there. So Michael, what's the best way to think about all these different scaling solutions? Is it vertical scaling versus horizontal scaling solutions?
You mentioned kind of grouping into vertical scaling and then horizontal scaling. And I think that is one axis of how I would categorize scaling solutions. I would add a second axis that would be, is it low level? Is it like in L0 or L1? Or is it an L2 scaling solution? And sort of conceptually to think of it in the computer science terms, because I do think that's a really helpful way to conceptualize it, because I don't think the problems we are trying to solve in blockchain are problems that are unique to blockchain. So the vertical versus horizontal is, you could think of it, am I increasing my single threaded throughput? Am I making optimizations that allow this one particular program to run faster? Those are important optimizations, right? Just because I have a ton of hardware to throw at the problem doesn't mean I want individual programs running slowly. Essentially making the execution of those contracts faster is vertical scaling. So transaction pipelining goes into that, as well as VM optimizations. Making the WebAssembly VM more efficient actually improves our scaling because we can run smart contracts faster. Versus the horizontal scaling would be parallel processing, right? Well, I can write a program that now has multiple threads of execution. And so because of that, I now have access to more throughput, or even taking that to the extreme and looking at abstracting a problem so it can be ran in parallel on a supercomputer. And that then highlights what I think is the other dimension, which is, are we talking about software solutions, right, which are L2 solutions, or hardware solutions, which are analogous to L0/L1. Transaction rollups are a vertical L2 solution, right? They're going to increase my transaction throughput because I'm not actually having to execute the transactions on the L1, but I'm still running on a single L1. And so that is a vertical scaling that takes place in L2. Parachains are horizontal scaling because I'm not increasing the direct throughput of any one chain, but I'm creating a protocol by which multiple chains can now be executing in parallel and have a protocol that can interrupt between all of these different chains. If I get really low level doing, say, transaction pipelining, that would be a vertical scaling within the L1. And then sharding is horizontal scaling within the L1 of actually separating out the database or something like that. So that I would add that dimension, and then I think everything from my perspective kind of fits neatly into that chart somewhere. And certain solutions are more horizontal than others. That would be the lens that I would be using to look at all of these solutions, taking that directly from how I would look at scaling on optimization solutions from a computer science perspective as well.